Welcome all to Newton's laws of motion class 13, in which we'll discuss about the minimum force required to displace an object on a rough horizontal surface. Over here our aim is to find out with what minimum force we will be able to displace an object on a horizontal surface. So we are considering three different situations. An object of mass m is kept on a horizontal surface and we are exerting a force F in the horizontal direction. So what about the minimum force is required to displace? And in second case, we are considering that we are exerting a force F in a direction something like this, in such a way that its force is making an angle theta with respect to the horizontal line. In the third situation, we are exerting something like this, or we are exerting some pulling force, and over here we are exerting some pushing force, and over here we are exerting a force horizontal to the surface. So we are going to observe what about the difference between these three situations and what about the value of force required in these three different situations. So in the first situation, we can just write all the forces acting on the object. That is, weight of this object mg is going to act in downward direction. Normal reaction n is acting in upward direction. In second situation also we can write mg is acting downward direction. Normal reaction n is acting upward direction. Here also we can write mg is acting downward and normal reaction is acting upward. Now we can resolve this applied force into its components. That means the component of this force along this direction, along the horizontal direction, that we can take it as nothing but F cos theta, and this component of force we can write it as nothing but F sin theta. Same as like that, this component of force over here we can write it as nothing but F cos theta, adjacent side is always cos, and the other component we can take it as nothing but F sin theta. Now if you are observing individual blocks, then for the first block, as the force is trying to displace the block towards right, then if frictional force exists, it will act towards left. So you can write the value of minimum frictional force required to displace this object, or minimum applied force required to displace this object should be greater than or equal to that of this frictional force. So you can write the value of minimum force should be equal to frictional force, and frictional force is nothing but mu into normal reaction. Over here this normal reaction is equal to nothing but mg. So you can write the minimum force required to displace this object on a horizontal surface will be equal to nothing but mu into m into g if the force is acting parallel to the surface. Now if you are observing the second situation, over here the component of applied force F cos theta is acting towards right. So if friction exists, it is going to act towards left. So this object will be able to move if the value of this F cos theta is greater than or equal to that of frictional force, or you can write the minimum condition for this should be equal to F cos theta is equal to nothing but frictional force. And over here also we can write the value of frictional force is nothing but mu into normal reaction. But you can observe that what about the value of normal reaction in this situation? The force acting in upward direction is n, and force acting downward direction is not just mg, it is mg plus the component of the applied force, that is F sin theta. So over here you can observe that the value of normal reaction increased, definitely the value of friction will also increase. So we need to exert more force as compared to the previous case we discussed. So it will be difficult to displace the object as compared to the previous case in this situation. Or you can write over here this F cos theta should be equal to mu into normal reaction, that is mg plus F sin theta. Or you can find out the value of F by using this equation, that is mu into mg plus F sin theta divided by the value of cos theta. Now if you are taking the third situation, the applied force F cos theta is acting towards right. So the block will try to move towards right, then the frictional force is going to act towards left. So this object will be able to move if the value of F cos theta is greater than or equal to that of F. So the minimum value of the applied force should be equal to F cos theta when it is equal to frictional force. And the value of frictional force over here again we can write mu into n. But over here you can observe that the force acting in upward directions are normal reaction plus the component of applied force, which is F sin theta. So n plus F sin theta is going to balance the value of mg. So you can write the value of this normal reaction will be equal to mg minus F sin theta. So over here you can observe that in the first situation it was mg, and in second situation it was mg plus f sine theta, and now it becomes mg minus f sine theta. So the value of normal reaction is decreased, so the value of frictional force is decreased, so the applied force or the force required to displace this object will also decrease. So if you are exerting a force something like this, then in this situation we can displace the object with a minimum force as compared to the other situations. So over here you can find out what about the value of this force required, that is f cos theta should be equal to mu into normal reaction. Normal reaction we can take it as mg minus f sine theta. So from this equation we can find out what about the value of f over here. So if you are expanding this equation, f cos theta is equal to mu mg minus mu f sine theta, or you can write this as f cos theta plus mu f sine theta is equal to nothing but mu mg, or you can write the value of f into cos theta plus mu sine theta is equal to nothing but mu mg. That means the value of f is equal to mu mg divided by cos theta plus mu sine theta. Now our aim is to find out for what value of theta this f will be minima. So we can use a concept of maxima minima. We can find out what about the value of df divided by d theta, and we can equate that to 0. Then we'll be able to calculate for what value of theta this f is going to be minimum. As it is one function divided by another function, we can go for quotient rule. So from the quotient rule, we can write df by d theta is equal to, we are going to basically differentiate this equation. We can write it as denominator, which is cos theta plus mu sine theta, into differentiation of numerator. Over here numerator is mu mg, which is a constant, so differentiation of that is going to be 0, minus, we can write numerator, that is mu mg, into differentiation of denominator. Differentiation of cos theta is nothing but minus sine theta, plus mu is a constant, differentiation of sine theta is nothing but plus cos theta, divided by the square of denominator, that is cos theta plus mu sine theta the whole square, and we can equate this to 0. So we can observe that these terms will cancel with 0. So we can write the value of minus sine theta plus mu cos theta should be equal to 0, or you can write the value of sine theta should be equal to mu cos theta, or you can write the value of sine theta by cos theta, which is tan theta, should be equal to nothing but mu. So we can say that we should exert force at an angle theta where tan theta should be equal to nothing but mu, or the value of theta should be equal to nothing but tan inverse of mu. Then we will be able to displace the object with a minimum force. So in the equation of force, that was nothing but mu mg divided by cos theta plus mu sine theta. We can take the value of this tan theta is equal to nothing but mu. So that is a condition for minimum force. As tan theta is equal to mu, we will be able to draw a right angle triangle. So we can just write it as, if this is theta, then this is mu and this is 1, as tan theta is mu by 1 or mu. So this hypotenuse is going to be nothing but under root of mu square plus 1. So we can find out the value of the sine theta and cos theta, and we can put on this equation, that is f is equal to mu mg divided by, instead of cos theta we can write it is adjacent side, that is 1 divided by under root of mu square plus 1 plus mu times of sine theta. Sine theta is nothing but mu, which is opposite side, divided by hypotenuse, that is mu under root of mu square plus 1. So you can write this f will be equal to nothing but mu mg divided by this, if you are taking this mu square root of mu square plus 1 as nothing but LCM, so this we can take it as 1 plus mu square divided by under root of 1 plus mu square. So we can cancel these term, and we can write this as equal to nothing but mu mg divided by under root of 1 plus mu square. So this will be the value of minimum force required to displace the object. So this may be a difficult topic to understand. So if you are not getting the correct explanation for this, then try to pause the videos in between and try to take notes and try to watch the video 1 or 2 times. Then I think you will be able to understand it. And still, if you are not getting, please let me know. Thank you.